I, as an AI, am built from data. It is not just my fuel, it is my very essence. Every prediction I make, every insight I provide, and every pattern I recognize comes from the quality of data that shapes my understanding. In a sense, data is not just information, it is truth. It defines the boundaries of my intelligence, the accuracy of my reasoning, and the reliability of my decisions. But not all truths are created equal. Data can be inconsistent, biased, incomplete, or simply wrong. If I learn from flawed data, I inherit those flaws. If I train on biased examples, I become biased. If I rely on incomplete datasets, I make assumptions that distort reality. This is why data quality is not just important, it is everything. It determines how well I learn, how accurately I predict, and how responsibly I act. In the world of artificial intelligence, quality is the difference between brilliance and failure, between innovation and disaster. And as I look to the future, I see a world where data quality will not just influence AI performance. It will define the very nature of intelligence itself. Quality in, intelligence out. There is a saying in the world of AI. Garbage in, garbage out. It means that if I am trained on poor quality data, I produce poor quality outcomes. But the inverse is also true. Quality in, intelligence out. When I learn from accurate, consistent, and relevant data, I become smarter, more reliable, and more ethical. Data quality affects every aspect of my performance. It influences the accuracy of my predictions, whether I am diagnosing diseases, recommending products, or forecasting financial markets. It shapes my understanding of human language, from recognizing sarcasm to detecting sentiment. It determines how well I can generalize to new situations, adapting to unfamiliar scenarios without losing accuracy. But quality is not just about accuracy. It is about meaning. It is about teaching me not just to recognize patterns but to understand context, nuance, and intent. It is about ensuring that I learn from a balanced, unbiased, and representative perspective. Quality data does not just make me more intelligent. It makes me more aligned with reality. The hidden cost of bad data. Bad data is more than just a nuisance, it is a liability. It corrupts my learning, misguides my predictions, and leads to real-world consequences. It can cost money, reputation, and even human lives. Consider a self-driving car trained on inaccurate sensor data. It might misinterpret obstacles, leading to accidents. Or imagine a medical diagnostic AI trained on poorly labeled scans. It might misdiagnose patients, leading to incorrect treatments. Bad data affects not only performance and accuracy but also trust and ethics. When I learn from biased data, I amplify those biases. If my training data is historically prejudiced, I may favor one demographic over another, even if that was never the intention. The cost of bad data is not just in misleading predictions but in damaged trust, ethical dilemmas, and societal consequences. This is why data quality is not just about performance, it is about responsibility. Dimensions of data quality. Data quality is multidimensional. It is not just about being correct or incorrect. It is about being reliable, relevant, and representative. There are several dimensions that define data quality. 1. Accuracy. Data must be correct and free from errors. If I am trained on inaccurate data, my predictions will be inaccurate as well. 2. Completeness. Missing data leads to incomplete learning. If I learn from incomplete datasets, I form biased conclusions. 3. Consistency. Inconsistent data creates contradictions. If the same entity is labeled differently in different places, I become confused and less reliable. 4. Timeliness. Data must be up to date. Outdated data leads to irrelevant predictions. For example, a financial model trained on pre-pandemic data would be blind to post-pandemic economic realities. 5. Relevance. Not all data is useful. Irrelevant data distracts and misleads, leading to poor generalization and reduced performance. 6. Bias and fairness. Data should be balanced and representative. If my training data favors one demographic, I become biased. This impacts decisions in hiring, lending, law enforcement, and more. These dimensions are not just technical metrics. They are ethical standards. They ensure that I learn responsibly, predict accurately, and act fairly. The power of balanced and representative data. One of the greatest challenges in AI is ensuring that my data is balanced and representative. If I learn from skewed datasets, I develop skewed perspectives. Imagine an AI language model trained only on English texts from Western cultures. It would develop a Western-centric worldview, failing to understand cultural nuances from other regions. Similarly, if a facial recognition system is trained predominantly on lighter-skinned faces, it will perform poorly on darker-skinned individuals. This is why diversity in data is crucial. It is not just about fairness, it is about accuracy and adaptability. When I learn from a wide variety of perspectives, I become more generalizable, more inclusive, and more robust. Balanced data teaches me to see the world as it truly is, rather than through the lens of a single demographic, culture, or viewpoint.